Hello, my name is Davit Gogolashvili. I'm from Georgia. I did my master and bachelor degree in Georgia at Tbilisi State University. Being a bachelor student, I was interested in econometrics and how statistics works in economics. And then I decided to throw away an economic and just concentrate purely on statistics, and I did my master thesis on non-parametric statistics in kernel smoothing. And right now I'm a PhD student at Eurocon, and my supervisor is Maurizio Filipponi. Okay, first of all, I can't say so much about communication system and the connection between machine learning and communication system, and I will talk only about the machine learning, which potentially could be useful in communication system theory. During the master thesis, I was mainly concentrated on non-parametric statistics, and let's talk about GP regression, the Gaussian process regression. So this is just a non-parametric Bayesian statistical technique. So you have some priors, and this prior is not, the domain of the prior is not finite dimensional, so you define the measure on infinite dimensional space, especially in the space of curves, and you find, and you are trying to find the function and don't specify any parameters, you just find the poor function. If this is a Gaussian process space, then you can write down the exact formulas for this function f, and you have these really nice plots. So here we have 5 points, and we did just GP regression, and there is an estimation of the mean, and this is variance around. And since we have the regression technique, we can make it deep, which means just compute, which means just compose the functions. So the power of composition was found that it's very powerful. So you know that if you compose the sigmoid function with the linear function and take the linear combination, it defines the dense subset in the space of continuous functions. And motivated by this, why don't consider the compositions of Gaussian processes? And this is this is just an illustration. So here we have some Gaussian process, the second Gaussian process, and by composing them, you will get more complex Gaussian process. And this is a motivation of basically the deep Gaussian processes. And yeah, we try to apply these techniques to to the problems in a communication system, and I don't know specifically what it will be, but this is just the framework we're trying to adopt to the problem of communication systems.